All right, folks. Hope you're doing well. Good morning or afternoon, whenever you see this video. Um, Obviously, this is Mr. Rocco. I'm doing okay. I'm gonna keep this video as short as I can. I've tried making this twice now, and it's been like 16 minutes or 15 minutes. It's just too long. So bear with me. Hopefully, I don't cough or sound too scratchy. Um, and hopefully, I can help you out with what you're gonna work on today. All right. So you guys can read the directions, but you're going to work on the same problem that you did yesterday. There are some things that I think that you guys need to fix or take a second look at from what I saw. Those of you who were in school yesterday and didn't open this, you might need to send me a message in Schoology. I marked in Schoology like that you basically that you're incomplete, because if you were absent, then you'll work on it today. But if you were here, you should have done something. You should have opened something. So if I put an incomplete in error, let me know. Not that you're gonna like get a zero or anything, but I am keeping track of the fact that you're gonna do work. Right? All right, so let's get moving. I don't want to make this too long. So let's talk about the bunny and the cat. Bunny and the cat each have their own starting value, their own growth. Basically, the bunny starts weighing less but gains more every year. The cat starts with more weight and gains less every year. So the bunny will eventually catch up to the cat. Now, a couple things. If we were to create an equation, and you don't have to until the end, really, but it might be nice, is to create an equation for the bunny. The growth is 3, so 3x, and the 5 is the starting value, so plus 5. So essentially, 3x is the 3 is the growth. But what does the x represent? Well, it says 3 pounds per year. Per year. X is the number of years. And then the y would be your total weight. So a couple things that I noticed yesterday. Some people didn't have labels. Oops. I would definitely put these. At the very least, you should know what they mean. I mean, heck, you could put them up here. You could say x is the years, and then over y is that might be a good idea, so you have some extra room. But if you don't really need it, to be honest, but whatever you got to do if you want to add it there. But a couple things: the x should be on the left. That's something that I noticed some people had some issues with. The x should be on the left, y should be on the right, and some people didn't include 0, folks. The bunny, it was kind of like born at 5 pounds, and then you add 3 pounds every year. So after 1 year, I mean, even if it wasn't born at 5 pounds, maybe she bought the bunny at 5 pounds, and then it gains 3 every year. Either way, time 0 is when she either bought it or the bunny was born. Same thing with the cat. So make sure you put 0 in there. Okay, so fix up whatever you need to there. But eventually it does meet. The bunny catches up, and the question that you want to answer is, well, when will the bunny and the cat weigh the same? Well, 7 years, 26 pounds. And this answer should hold through everything. But make sure to write that, highlight the row where they meet. Now, 7 years, 26 pounds, this is where they should meet. So when you go to graph, and again, if you want to do it on paper, it's probably going to be easier. This isn't so bad, though. I didn't see a lot of people try this, but it's not so bad. I did see some people mixing up the x and the y. Make sure your x, which was years, right? Above in the table, x is years, so x is years here. And y was weight. Y is weight here. So fix this up if you need to. This is not particularly hard. I know it looks like I did a lot, but all I did was I created a text box here, spaced out my numbers, created a text box here. This could have been in the same text box, but I did it separately. And then these points, all you have to do to create a point is shape, make a circle. Obviously not that big. And then I Control C, Control V a bunch of times. And I just line them up. I put them on my graph, I line them up. And to change the color, you just hit the little thing, Maybe do that before you copy and paste. Just an idea. Once you get it all lined up, though, you go to this line here. You hit line, drag and drop. Of course, that didn't work for me. Try one more time. Drag and drop. A line through it. Or like a line through it. So I know that was a silly way to do it, but it's not so bad. It doesn't take as long as you think. So anyway, you line it all up, and you can see mine's not perfect. I have a bunch of this one's way off, this one's way off, or not way off, but it's off. But ultimately, you find the same thing at 7 years, 26 pounds. So same thing as when we were graphing. You find the same thing. So I'm going to let you hash that out. Again, after 7 years, the animal weighs 26 pounds. So here's the new stuff. You guys can create the equations. I trust you created the equations. You got your growth, you got your starting value. But ultimately it says set the equations equal to each other and solve for x. This is new. This is something different. So I'm going to show you how to do it. But you can kind of get the idea right here at the very least. Ultimately, you can't really solve unless you combine these equations somehow. And we only want one variable. We want to solve for one variable, then the other. But we want to find where these are equal. So what you do is, to accomplish those two things, we want them set equal to each other in one variable. We can do that because they're both y equals. So you can kind of put the x part of each equal to each other. So let me jump over here and do that real quick. You're going to take this and this and set them equal to each other. So it will be 3x plus 5 equals 1x plus 19. Again, we want these to be equal to each other, and since both are y equals, you can basically just take the x part of each and set them equal to each other. This is called equal values method, and think about it, that makes sense. You're setting two values equal to each other. And let's solve. And I hope you realize what the answer should be. We want to find where they're equal. Subtract 1x from both sides. Subtract 5 from both sides. You guys know how to solve an equation. I'm going to move pretty quick. You'll have to write this work down. Feel free to pause this video. But what do you know? You got 7. That's years. All right. And we found it on the graph. We found it on the table. Sure as heck should find it on here. Now let's find the number of pounds. So at 7 years, they're going to be equal. Let's find the number of pounds. So take one of your equations. I'm going to use this one. I guess it's kind of funny I picked that color because that's the color I had this equation in up here. Doesn't matter which one, by the way. You could do 1x plus 19, y equals 1x plus 19, or y equals 3x plus 5. But basically, we found x, so take x and plug it in. 7 in for x. 7 times 3 is 21, plus 5. There's your 26 pounds. I'm not going to try and write pounds there. I don't really have room. Okay. So there you go. It's a two-step process, but we want to find both variables. We need to set them equal to each other. So because they both say y equals, put them equal to each other, do the steps to solve the equation, plug your other variable in, got your answer. So you could type it up if you want. It looks like this. And then, you go like this, maybe create your equal sign, and then, something like 2x plus 5 is 19, and go from there. You type it up or write it, whatever you got to do. All right. But ultimately, you do need to solve this problem now, the one about the populations. Each school is going to have its own growth and starting value, create an equation, set them equal, and solve for when will the populations be the same at the schools. All right. Have a great day, everybody. Talk to you later.